Hello everyone. In this video, I will show you how to answer question 1 of reinforcement exercise 3. So this is the question that I have copied down. 100 grams of concentrated sulphuric acid solution contains 15 grams of water. Calculate the molarity of the acid solution given the density of the acid solution is 1.69 grams per ml. Okay, so in this question you are given the mass of the acid solution, and in that solution it is composed of 15 grams of water and some sulfuric acid. So from this information we can find the mass of sulfuric acid alone. And then what you have to do in this question, you have to calculate the molarity of the acid solution given the density. So you have the density, you need the molarity. So now let's have a look on how to tackle this kind of question. So first of all, you want to find the molarity. So we write down the formula. Molarity of H2SO4 is equals to the number of mole of H2SO4 in the solution divided by the volume of solution. Okay. So first of all, we need to find this as well as this, the number of mole and the volume of solution. So if we want to find the number of mole of sulfuric acid, we can find the mass first. So we need to find the mass of sulfuric acid. So the mass of sulfuric acid is equals to the number of mole of equals to the mass of solution minus mass of water, because in this solution the total mass is given, which is 100 grams, and you are given the mass of water, so you can find the remaining, which is sulfuric acid. So 100 grams minus 15 grams, so you should be left with 85 grams of sulfuric acid. And from this you can find the number of mole of sulfuric acid. It's equals to mass of sulfuric acid divided by the molar mass, and this should be equals to 85 divided by, so 2 multiplied by 1.0 for the molar mass of hydrogen, plus sulfur, which is 32.1, plus 4 times by 16.0, and you should be left with 85 divided. If you're using the same calculator as me, make sure you use brackets to make it easier to calculate. If you do not use this version of a calculator, make sure you do it step by step. So you should have 0.8665 mole. So make sure you take at least 4 significant figures, because this is not the final answer yet. And from this you have to find we have found the number of mole. And now we want to find the volume of solution. The volume of solution, we can use the density information that we are given. Density rho of solution is equals to mass of solution, which we are given, divided by volume of solution. And in this case, in this situation, the density is given in grams per ml. So we do not need to change the volume, well, we do not need to change anything to any other units. So 1.69 equals to 100 divided by V solution, and V solution equals to 100 divided by 1.69. So 100 divided by 1.69. So you have the volume it's a small volume, 59.17 ml, as we are given in grams per ml. So now to find the molarity, M of H2SO4 is equals to the number of mole, which we have calculated, 0.8665 divided by the volume. However, molarity is always defined as the number of moles of solute per liter of solution, which means that the volume has to be converted into liters. So to convert it, you divide it by 1000, and you should get the final answer. 0.8665 divided by 59.17 divided by 1000. So you should get the molarity of 14.64 mole per liter, and it can also be written as 14.64 molar. Okay, so this is the working on how to tackle this kind of question. So make sure when you try, and next time when you try to do similar questions, you first focus on what we want to find and look at the informations of what we are missing of and what can be calculated. Okay, so that's all for this video. Thank you very much.